Hello, my name's Andrew Grigsby. I'm with Commonwealth Sustainability Works, and I'm a home energy rater. And we're here today at the clubhouse of Forest Lake Subdivision in Charlottesville, Virginia, to go through basically a home energy audit. Of course, this is not someone's house, but it's going to have many of the same features that you might encounter in your house. We're going to look at issues of air sealing, insulation, appliances, doors, windows. So we're going to do a little detective work, and we're going to come up with a list of suggestions for how this building can be more efficient, and also how you can learn how to be more efficient in your own house and save some money. Here we are in the unfinished part of the basement, and it looks probably a lot like your house looks. We've got some uninsulated masonry wall. We've got some insulation above. This is called the band joist. It's where the floor joists intersect the perimeter of the building. And it's a space that tends to be very leaky. The air just moves right through the fiberglass, and the fiberglass just filters it. What I would call for in this location is to take the fiberglass out of the band joist area and re-insulate that with spray foam, which it sprays in and expands out. It fills every hole. It stops all the air movement. We're here at the heating system. We've got a heat pump, and which is a good way to heat and cool in this climate. The other thing about having an efficient heating and cooling system, it's going to be the air filter in it, and your air filter might be at one of your return vents. This one's here at what we call the air handler. This one's very clean. After a while, as they get clogged up, the fan has to work harder to move the air through. For some reason, we've got some of the tape coming loose. I always recommend using mastic, which is a paint-on adhesive, which is going to perform a lot better than tape. Basically, the point is do everything you can to make this system as airtight as possible. Heating water. The average house puts at least 10% of total energy use into water heating. It can go up to 15%. But basically, good test to see how efficient, how well insulated it is to just put your hands on it. What we can do is add a layer of insulation to it. You can buy a blanket of insulation at a home improvement store. Wrap it around this. You also want to check the setting. 120 degrees is a good setting. The other thing we can do to make this more efficient is to insulate these pipes. If you think about it, this is a hot water pipe running from here to every bathroom in the house, and it's losing that heat the whole way it goes. So you can get hotter water quicker at the bathroom on the second floor if you insulate all the pipes. I can feel a little cold air. There's not a big breeze coming out of there, but canned foam that you can get at a home improvement store, just filling this area with that canned foam will again add a little R value to the spot, stop any air movement. Here, someone has kindly removed the grill so we can see, and you see the gap between the drywall and the metal. If we were on the second floor, that would be a gap right straight to the attic. And all it takes is caulk. So in your own house, just take some regular caulk and seal that gap between the drywall and the metal. And you'll prevent all that warm air from rushing to the outside. Very cheap, very effective. Electrical outlets tend to be places where you might get some wind blowing through. And you can buy foam gaskets that you put underneath the cover to help stop that. If you're feeling air blowing underneath the baseboard, you can remove the shoe mold and caulk behind it and put the shoe mold back to stop that air from leaking underneath. If you look up here, we've had the access to the attic, and this tends to be a real problem area in lots of houses. It's a door to the outside, and we need to make sure it's well insulated. We also need to make sure it's weather stripped. This one looks like it's just a piece of plywood, and there's probably no insulation on the other side. This is the vertical wall that abuts the cathedral ceiling area in the great room on the other side. So lots of houses are going to have spaces like this where you've got, rather than an insulated floor in an attic, you're actually looking at a wall. And this is a real problem for several reasons. One, you can see here there's a whole bay between studs that they left uninsulated. And again, it's at the highest point in this house, so that's where all the warm air is going, and it warms that space up. If there are air leaks, the warm air gets out, This is the outside of what we call the thermal envelope of the house. So it needs to have an air barrier. It needs to be sealed. And a real layperson might come up here and look down, and here we're looking down and we see R30 right there on the insulation. And they might think, oh, great, my attic is R30. But again, it's important to make the distinction between what you read and what the installation quality is actually delivering. As I pick up this piece of R30, it's not doing much at all. Insulation needs to fill all the gaps, needs to fill around it and cover everything. So this is not doing the job. Over here, it's hard to tell what's going on. There's just stuff scattered all over the place. And over here we have a recessed light, which is completely uncovered. Now, old recessed lights were not designed for what we call insulation contact. And they'd get very hot, and that'd be a problem. You need to make sure, do you have insulation contact rated recessed lights? And if you don't, just replace them. Get the new modern ones that are. Here we are learning a little bit about how the television uses energy. And what we have is this little device that the television is plugged into it, and it plugs into the wall, and it's telling us the flow through of wattage. So right now, to operate, this television is using 88 watts. And now what we're going to do is turn it off. And I think most people would assume you turn the power off on something, it isn't using any more power. Well, our little device here is telling us that actually this is still using 57 watts. So even when you think it's off, it's still using the same as a 60-watt bulb, 24/7. And if you think of all the TVs all across the country sitting there, it's pretty amazing how much energy we're just throwing away. Appliances which are plugged in and have a light on are using energy. Put all your electronics, or the ones that make sense, on a power strip. That way you can just, if you walk out of your office at the end of the day, just hit that power strip and everything's off. We're going to talk a little bit about lighting. Lighting is a major energy user in your home. 10, 15, 20% depending on your house. And here in this public building, I mean, your house probably doesn't have a men's room, but you'll notice how that, as I open the door, the light back there cut on. It's on a motion sensor. And you might find that there are places in your house where photosensitive or motion sensitive lighting would be appropriate. There's other compact fluorescent lighting. And this is a good example where here's a bulb that looks just like an incandescent, but actually it's a compact fluorescent. And compact fluorescents now, they come in they're not just the curlicue ones. They come in a round bulb. They come for chandeliers. They're dimmable. They come in a more yellow all the way to a more white light, so in all different shades. And they'll use 2/3 less energy on average than your incandescent bulbs. So it's a great way to save some energy. This is the thermostat for the upstairs portion of this house. And it's a programmable thermostat, which is a great thing. What that allows you to do is have the little brain inside this cut the heat on and off when you want it. So it's not keeping the house warmer than it needs to be when there's no one here or at night when you're sleeping. It's a very effective way to save energy. Could be up to $100 a year, depending on the house. One issue with water heating is how much water you end up using coming out of the faucet. And the aerators are good if you reduce the amount of water coming out. So you use less water to do the same work, and that's good for saving energy when you're talking about hot water.
The energy audit also will include the rater looking at the household energy bill. The purpose of this is to determine if there's anything peculiar going on that may not be evident from the walkthrough or from the testing. And all of this information should be included in a detailed report that the energy auditor will provide to the homeowner after the whole process is done. And the report should list what are the recommended improvements, sort of prioritize those improvements, hopefully maybe provide some cost estimates, so that can be a hard thing. The report is really a crucial part at the end of this process to give the homeowner something they can do to take as a document, to learn from, and then to go out and speak with different contractors about getting the work done and actually start saving some money.